Alright, year 11. So, as promised, I said I was going to do paper Exam 1 and Exam 2 tonight for 2017, past exam 2017. So, please download it. If you don't know where, remember you can access this Unit 2 past exams here from your Schoology, or if you've gone to your Google Classroom. I remember putting up a link there already. But just in case, you can log into, I'm just going to log into Schoology just to show you in case you have no idea how to access your past exams in your Year 11 Maths Methods course. I put it into exam resources and it's that link right here. So sometimes if you click it and nothing comes up like my one, just click the title again. So if you click the title, it will take you to the Year 11 Maths Methods, or Year 11 just in general maths resources. So you get general maths, maths methods, specialist maths, maths methods, and then obviously, you know, exams, and we're doing Unit 2, and in Unit 2, you got 15, 16, 17. So I'm doing 17 today, and it's probably gonna take a while to upload as well. So I'm going to expect that tomorrow in class session 5, you'll be using that time to do the past exam. For those who haven't done SAC 1, you'll be doing that in session 5. And then you do the common assessment task in session 6, where you can use a CAS and a bound reference. Okay? But for those who have done SAC 1, then the teacher should be handing out your SACs, because I was meant to give it to you today, and I forgot. We were so into the CAS stuff that I forgot to hand it out. But the teacher should hand that out to you. And yeah, I want you to work on 2017 past exam first, and then you know, look at the solutions, look at my videos if you know you're still having troubles with it. Really try to learn the techniques on the CAS and the theory, okay, the conceptual theory. And my suggestion is stick to past exams, because you only got 5 days. You got all these other subjects to worry about as well. So do the past exams. Don't go back to your textbook and try to do all the exercises, then do the past exam. You'll be overloading yourself, and you don't have enough time, and it's not studying effectively. So I'm telling you how to study effectively, okay? Do the past exam. Do the past exam. Even if you don't know how to do it, look at the solutions. Read the solutions, try to learn from that. Watch my videos. That's a better approach than trying to go into your textbook. Okay, but anyways, since it's going to be a long night, let's not waste more time. Let's begin. Here we go. So this is exam 1, technology free. You only get a formula sheet and no CAS. All right. Things to pay attention when you're doing this. It tells you a decimal approximation will not be accepted if an exact answer is required. Please, when you're doing the exam, it does matter whether you're going to give it in decimals or not. Now, most people like to give it in decimals because we're good at decimals and we hate fractions, right? Be mindful of that, because you will lose marks if you're doing that. Okay, now, let's read the first question. It says, question 1, 5 marks. Okay, so here we go. We've got a function, f, 0 to 2 pi, so that's the domain. And it is a cos of 2x with an amplitude of 2. So I'm just going to write here. Remember, the number multiplied to cos or sine or tan, actually not tan, only for sine and cosine. That number at the front tells you the amplitude. Now, most of you did the SAC really well on this one. Amplitude tells you that in your graph, the median, so in a cos graph, this is what normally a cos graph looks like. It just means that the height from here to here is 2. That means from the height from here to here is also 2. Okay, it's always from the center. If you were to cut it into halves, then the height, the maximum height to the center or the minimum height to the center is 2. That's what it means. Okay, in our particular case right now, it's a positive cos, so I've pretty much got this type of shape of graph. I've got that, and it's apparently all the way to 2 pi as my domain, but keep in mind, you also have to find the period. So in order to do this one cycle, how long does it take to make one cycle? The question is, how long? Okay, now how do you find the period? The period is given by, oh, what's going on here? Like, I don't even know what that is. All right, here we go. Period. Seriously, what is going on? Here we go. Period is equal to 2 pi on n. N is the value multiplied to x, the coefficient of x. In our case, it's 2 as well. We've got another 2 here. That's my n value. So that means it's 2 pi on 2, and 2 divided by 2 cancels out, so I have pi. So what does that mean? It just means that in order to start at one point and I reach back at that same point again, it takes pi units. Okay? And that means that if I did another cycle from the top to the bottom, there should be another pi units. Pi plus pi gives you 2 pi, which actually is the domain. Okay, so what I can see is the graph doesn't move left or right. Okay, and it doesn't move up or down. If it moves up or down, you would have had a +1 or a -1. So really, I've pretty much just drawn my graph there. So it says here, on the set of axes below, sketch the graph of y equals f of x, showing axial intercepts and endpoints. Okay, so make sure you give that to get the 2 marks. So here we go. Starting at the top, going all the way down, come back up. Oh, actually, I made it too big. Let's make it a bit thinner. Here we go. There we go. That's a nice graph. And I know that it finishes at 2 pi. Remember, it reaches this one cycle was pi. What was the amplitude? We said it was 2, so the maximum value had to be 2, minimum value had to be -2. So I would normally label my coordinates on my endpoints. This would be when x is 0, y is 2, and clearly over here, when x is 2 pi, y is also 2. Okay, so I've got my endpoints. I haven't got my axial intercepts. Okay, so these are the stuff I'm missing here. Now, logically, you can figure this out because remember, the graph is broken up into quarter cycles. So if you watch over here, I'm just breaking up to quarter cycles here. That's there, there, and there. So if you really think about it, when you draw your cos, there's a quarter from here to here. So it stops there. And then from here down to the minimum, that's another quarter. And then from the minimum back to the center, that's another quarter. And then from the median to the maximum, that's another quarter. Okay? So because it's evenly split, if this is pi, then the middle has to be pi on 2. Okay? So if that's right in the middle, then a quarter cycle will be half of pi on 2. So clearly this has to be pi on 4, and this has to be 3 pi on 4. If you're wondering how I knew it was 3 pi on 4, well, you think about it, it's quarter cycles, right? And I know the first point was 1 pi on 4, so the next part has to be 2 pi on 4. That's why it's pi on 2. And then the next one has to be 3 pi on 4. The one after that is 4 pi on 4, which makes it 1 pi. Yeah, 4 pi on 4. Like, listen to what I'm saying. 4 pi on 4. So there's 4 out of 4, which is 1 pi. And the next one would be 5 pi on 4. And then the middle would be 6 pi on 4, which really is 3 pi on 2. And then 7 pi on 4. And then 8 pi on 4, which makes it 2 pi. There you go. So notice I'm explaining this, so it's taking a bit longer to answer the first question, but really, you would just, if you picked up on the shape of the graph, I've just drawn 2 cycles. I use symmetry to help me find the x-axis intercepts. That you could have definitely done in less than 2 minutes. For 2 marks, should take you about 3 minutes, but surely we could have done that very quickly. Okay, so there we go. That's my 2 marks there. And then let's have a look at what's my next part. Solving the function f of x. So the f of x is 2 cos of 2x, and I want to solve it when it equals to 1. Now, visually, just in case you didn't understand, the y-axis, this is 1, this is 0 here, and the top value is 2. When you're asking when it equals to 1, clearly you should have 1, 2, 3, 4 solutions, because you can see it intersects 4 times. Okay, so I'm just going to rub this out so you remember that that's not actually the graph. I'm just drawing it so you understand what it means when we say solve the function to equal to 1. We're asking when is the y value 1, and it's right here. And your goal is to find those green dots, the x coordinates, okay? But here we go. Let's take a plunge into it. So we had 2 cos of 2x, and we want this to equal to 1, okay? In order to solve for x, because that's what they're asking me to solve for, I have to remove the 2, divide both sides by 2. Cos of 2x is equal to half, okay? So you're really looking at your unit circle. Hopefully you remember unit circle. You're asking cos. Cos represents the x-axis. And when is it positive half? The only time you're going to have positive is in the first and the fourth quadrant. And cos of what gives you half. Hopefully you remember your exact values through the hand method. In order to have half, it clearly is your ring finger. So I quickly draw it for you. This finger, if you drop it down, what you should have, 1, 2, 3, whoops. If you drop it down, and then, man, this is so hard to do. All right, so you drop the finger down, then, you know, cos is the number of fingers on the right-hand side. Clearly, I've got 1 finger. Remember, the rule was root of the number of fingers for cos, and cos is always on the right, sine is on the left, yeah? I've got root of 1 on 2. That's why it ends up being half. So this finger, the ring finger, is your pi on 3, which is equivalent to 60 degrees. Those who forgot, it's 0, 30, 45, 60, 90 degrees. Okay? There you go. So I know the angle has to be 60 degrees or the radians is pi on 3. So essentially what I'm saying is that from here to here is pi on 3. From here to here is also pi on 3. The angle is 60 degrees and the angle here is 60 degrees. Now, where am I working between? I'm working between, I'm going to zoom in a bit, between 0 to 2 pi. So you're starting at 0 and you're going to move around the circle until you reach 2 pi, hence a revolution. But every time you hit where the red lines are, that's one solution. Okay? Now, let's answer the question. And remember, I showed you 2 different ways to do this. I'm going to show you the long way so that you remember how to do it. But starting from 0, I'm going to move up and I hit my first solution after pi on 3 units. So here we go. I'm going to do 2x is equal to the cos inverse of half. We know it's pi on 3, but remember we have to account for all these solutions. So it was 0 plus pi on 3. That's my first solution. And then as I keep going around the circle, I get to pi. Haven't hit another solution, so I keep going. And I get to this end, which is 2 pi. But you see, I hit the solution over here just short of 2 pi by pi on 3. So really you would write here 2 pi minus pi on 3. Okay, now this gives me the first 2 solutions. I got pi on 3. Remember, this is still 2x, 2x. And this is 2 pi minus pi on 3, 6 minus, that's 5 pi on 3. Okay, I've got my 2 solutions. But what you have to remember, okay, what you have to remember is that, didn't we say that there should be 4 answers? Because clearly there are 4 answers here. Now, if you actually solve for this, if you divide both sides by 2, okay, so I'm going to do it in another color so you can see. This is x. If I want to find what x is, I'm going to divide this by 2, divide this by 2, divide this by 2. That will give me x is equal to pi on 6 and 5 pi on 6, right? 5 pi on 6 is 30 degrees. So you can see 30 degrees makes sense to be here. This is where pi on 6 is. And the next one that I just found, oh, it's over here, is 5 pi on 6. Okay, that's what essentially I found. But what about the other 2? Now, you could have changed the domain. Remember, I tried to teach you to change the domain. Forget about that. You get your first 2 solutions and trial and error. Means that add the number of periods that you have until you get out of the domain. So you had x equals to pi on 6 and you had 5 pi on 6. Then what I want you to do is trial and error the period. Now what was the period? You found out it was pi. So what you're going to do is you're going to add and subtract pi, add and subtract pi to see when will you pass 2 pi and when will you pass 0 in the negative direction and positive direction. Okay, so now just to make things easier, pi is 1 pi, and notice that this is out of 6. So really, you just really add and minus 6 pi on 6 because that is the same thing as 1 pi. Plus minus 6 pi on 6. So what I'm really saying is add 6 and minus 6. Now if I do that, okay, if I do that, that should give me these solutions. Now if I took pi on 6 plus 6, that gives me another solution of 7 pi on 6. If I got 5 pi on 6 plus 6, that gives me 5 plus 6 is 11 pi on 6. Now it just so happens these still fit in the 0 and 2 pi. So that was adding. Okay, I added this by pi, and I also added this by pi. Okay, so 5 pi on 6 plus pi is the same thing as adding 6 pi on 6. And that's how I got 11 pi and 6, right? But I haven't tried minusing. So let's try minusing. So take here minus 6 pi and 6 and minus 6 pi and 6. Okay? So really, essentially, I'm saying minus 6. So 1 minus 6 gives me now negative 5 pi and 6. Now that's way below 0. And then if I take 5, take away 6, it's negative pi and 6. And clearly, it's also below 0. So these solutions are out, but these still fit in the domain. So hence, my x solutions are here. And it makes sense. I should only have 4 of them, because graphically, you can see there's only 4 green dots. Okay, that's the only time you're going to cross them. So the answer for this is pi and 6, 5 pi and 6, 7 pi and 6, 11 pi and 6. Hopefully that kind of recaps your circular functions there. Okay, next one. These are very typical log and exponential questions. Okay, so I gave some of these in your SACs as well. Now, let's have a look. Remember I said for year 12 exams, if there's a number in front of log, one of the rules that most students overlook is number 3, where you put the power to the top, right? But in our case, we're pretty lucky. It doesn't have it. It's just an addition. Okay, so with the rules, when you add the logs, you will times the insides. Okay, so I'm going to simplify this problem by using log rule number 1. So I'm going to simplify as log 10 of, now it's 2x minus 1 multiplied to 2. Okay, because when you add them, you can simplify it as 1 log, and you multiply both the insides, so 2x minus 1 times 2, and on the right-hand side, still equal to 2, right? Now, if I expand it, this gives me log 10 of 4x minus 2 is equal to 2. Now, from here, the way I taught it in class is I said, how do you remove log base 10? See, the inverse of log is exponential. So if I want to remove log base 10, I would do exponential base 10. So here we go. On the left-hand side, I'll say 10 to the power of this the entire thing, and then 10 to the power of 2 on the right-hand side. Okay, if you're confused what I'm saying there, I'm just saying I am doing 10, so exponential, base 10 to the power of log base 10 of 4x minus 2. I'm balancing the equation, and then 10 to the power of 2. That's all I'm doing. Okay, but the nice thing is the inverses will cancel out. And if you've forgotten why this works, it's the same thing as saying, if I got x and I said add 2 and take away 2, that still equals x, true? If I got x and I said times 2 and then divide 2, it will equal x. Think about it, 2x divided by 2 is still x, right? And the same thing, if I said x squared and then square root it, it's still x, because I'm doing the inverses. So the same thing works when you say log 10 of x and then exponential base 10 of that. These two cancel out, these two cancel out, these two cancel out, these two cancel out. The theory stays the same. They're all equal to x. Okay? That was a very sort of quick way of me trying to recap you on logarithms. But anyways, here we go. So if those cancel out, what I'm left with on the right-hand side is 4x minus 2 is equal to 10 squared, which is 100. So nicely, this gives you 4x is equal to 100 plus 2 on both sides, so that becomes 102. X equals to 102 on 4. Okay, but you don't leave your answer unsimplified. You should simplify that. They're both even numbers, so this becomes 51 on 2. Okay, that's a better answer. And don't change that to decimals. They didn't ask. All right, there you go. So that's logarithms there. I just simply did, if you add, you multiply. If you subtract, you divide, right? Now, here we go. The next one, exponentials. Now, with exponentials, most of the time, it's about making it equivalent expression. Now, notice the bases are different. It's 4 and an 8. And there is no way I can do bases of 4 to get 8, because 4 to the power of 2 already gives me 16. Okay, so I can't get that 8. So what you were meant to do is break the 4 into their prime factors. See, 4 is the same thing as writing 2 squared. Agreed? Now, if 2 squared is 4, well, it's currently 4 to the power of 2x, so it's 2 squared to the power of 2x plus 6. This is equal to, now 8, instead of writing 8, I can write 2 cubed to the power of 3x minus 1. Why did I do that? Because now it gives me the same base. I have 2 and 2. Now, what was the rule for index laws? If you have the brackets on each side, you can multiply the powers together. So 3 times the 3x and 3 times the negative 1. So if I simplify this out, this is now 2 to the power of 2 times 2x, 4x. 2 times 6 plus 12 is equal to, again, now 2 to the power of 3 times 3, 9x. 3 times negative 1 minus 3. Why did I do that? Now, the reason why I did that is because if the bases are the same, and apparently it's equal to each other, that means the powers have to be equal. Okay, because it's pretty much the same equation. The only difference is the power. So the powers, if it's equal to each other, that means the power they have to equal to each other too. So therefore, 4x plus 12 is equal to 9x minus 3. Alternatively, if you didn't like that logic, you can remove the base 2. Now, how do you remove base 2? Inverse of an exponential. What is the inverse of an exponential? You got it. Logarithmic. Okay, so I can say do logarithmic base 2 on the left-hand side and logarithmic base 2 on the right-hand side. These two will cancel out. Log 2 and the exponential base 2. Log 2 and exponential base 2 cancels out, and you still end up with the same equation. 4x plus 12 is equal to 9x minus 3. Okay, and then from there, obviously, it's simple algebra to solve x. Minus 4x on both sides, so you get 5x minus 3 is equal to 12. Add 3 on both sides, 15 equals 5x. X is equal to 15 divided by 5, 3. Okay, but there you go. So 2 marks there. These are typical examples of doing logarithms. Now, let's go to the next one. Question 3, find the equation of the tangent. Okay, sweet. Now, we've just done our SAC 1. Hopefully, this is still fresh in your mind. Equation of a tangent line. So we already know it's going to be y equals mx plus c. So in order to find the equation of this straight line, you need 2 things. You need the gradient and the y-intercept. Now, how do you find the gradient? Don't forget, remember the purpose of derivatives. Calculus, everything that you've been learning in calculus was to do what? It was to find the gradient of a tangent line at one point. I think I repeated that so many times. And notice here it says at the point where x equals 1. You got 1 point here. So when x is 1, you don't know what y is, but you can figure that out. You got when x equals 1, you don't know what y is, but that's at 1 point. And your goal is to find the equation. So in order to find m, you have to find the derivative. Derivative tells you the gradient. Okay, so let's start off by finding the derivative. So here we go. F of x is equal to x squared minus 2. Then the derivative, using the power rule, hopefully you revised the power rule already. Derivative of x squared, drop down the 2, minus the power by 1, so it's 2x, and the derivative of any constant is 0. This is my derivative, but it doesn't tell me the gradient because I haven't told them where. I haven't told what x is, and it already clearly says x is equal to 1. So if I found the derivative when x equals to 1, it's 2 times 1, which is 2. What does that mean? It just means when x equals 1, the gradient of the tangent line there is 2. Okay, if I draw it visually for you, x squared minus 2 looks something like this. Okay, at x equals to 1, okay, I'm just saying that this point on the graph has a tangent line, and this tangent line is y equals 2x plus c, because we know the gradient is 2. That's essentially what you're saying there. Okay, don't forget the purpose. Really don't forget the purpose. This is exercise 18a, by the way. Okay, now you got m, so what's the equation of the straight line? You've got y equals to 2x plus c. How do you find c? Back to year 9 mathematics. You need an x and a y coordinate. Now, coincidentally, we do have x. We have x was 1, but we don't know what y is. So if x is 1, what is y? That's the question. But hey, you were given the equation to find y. See, this right here, don't forget what this means. This really just means I'll tell you what y is if you tell me what x is. So if I actually just subbed it in, if I subbed x equals 1 here, that should tell me what y value is. So I'm doing f of 1, which equals to 1 squared minus 2, and 1 minus 2 is negative 1. So really, the y coordinate here should be negative 1. So when x is 1, y should be negative 1. Okay, so sub that in, and what I should get is negative 1 equals 2 times 1 plus c, and that gives me 2, negative 1 plus c, and that's negative 3 equals c. Okay, And therefore, my answer, y equals to 2x minus 3. That is the equation of the tangent line, which means this is the point when x is 1, y is negative 1. And at that point, I've got an equation that I've just figured out that it's not plus a, it's minus 3. 2x minus 3. Okay, and that's the only two things you got to find. What was the hardest part? Finding the gradient. The rest is your simple year 9 stuff. You got x equals 1, find the y value, sub in the coordinate once you got the gradient to find c. Okay, it's the same drill over and over, right? You can look at all the worksheets I've given you, even the SACs that I'm returning on Wednesday, which I'm assuming that's when you're going to watch this video. You'll find that I did have one of the questions where you find the tangent, you find the normal. It's the same drill, okay? Next one. It says the function is equal to sine of 4x, and they want you to find the derivative when x equals to pi and 3. So first thing is you need to find the derivative. Now remember the rule that, and it's on your formula sheet by the way, if f of x is equal to sine of x, not 4x, then we know the derivative is equal to the cos of x. But that's the issue. We don't have x. We have 4x. So what are you going to do? You're going to use chain rule, the bread and butter. You're going to replace this 4x with a letter. Now, I'm going to call that u, and I'll show you why I do that. If I let u equal to 4x, why do I do that? Okay, it's always about the y, because if you really look at what you're trying to do, it changes the problem from f of x to now becoming sine of u. Okay, technically it's f of u, right? And just to make things easier, I'm just going to call this y, just to make it easier for you. I'm going to call this y, and I'm going to call this y, okay? Why do I like y equals sine of u? Because this looks so familiar to this. That means the derivative, when I say find dy du, it should equal to the same thing as cos of u. Not cos of x. Okay, so this would be cos of u. So that was nice and easy. I've simplified the problem. But you can't forget that you made up this variable here. And that's why you also have to find the derivative du dx. And derivative of 4x is 4. Okay, now remember the chain rule tells you dy dx is equal to dy du multiplied to du dx. Now I notice in your SACs, a lot of you guys are skipping this step. You're all jumping to this, and you just finished there. All right. Don't forget the u. You have to differentiate this as well. Don't skip this step too. Get into the habit. Okay. If you skipped and you got it right, fantastic. If you skip and get it wrong, well, don't do that. Okay. So dy du, we already got dy du, which is over here. That was cos of u. We got to u dx, which is over here, and that was equal to 4. So times 4, and that's 4 times cos of u. But remember, you're not finished. It's dy dx, not dy du. That u you made up. So we're going to replace that u again. It's 4 cos of 4x. That's the answer. Okay? Now, I haven't actually answered the question because I've just found the derivative. But remember that they told me I found f dash of x, technically. I know I'm calling it dy dx, but that's technically f dash of x. Your goal was to find out what is the answer when x is pi on 3. So f dash of pi on 3 just means find 4 times cos of 4 times pi on 3. Okay, now this is going back to your exact values. 4 times cos of 4 pi on 3. So where's cos of 4 pi on 3? If you have to figure it out. 4 pi on 3 is the same thing as writing 1 pi plus pi on 3. True? Okay, if you think about it, it's like 3 pi on 3 plus an extra 1 pi on 3. Yeah? And where's 1 pi starting from 0 here? Pi's over here, and I'm adding an extra pi on 3. So I know this is the region for cos. And cos is negative in this region. So if it's pi on 3, use your fingers again. Cos of pi on 3, it is half. So that's why it's 4 times negative half. Don't forget the negative. It's in the negative region. This is the negative cos region. It's where x is negative. This whole side here is negative. Okay, so this gives you now negative 2. That's the correct answer. Okay, negative 2. Unless I've done something wrong. Let me just double check. Now I'm pretty sure I'm right. 4 times negative half. Yep, that should be alright. Cool. I believe the answer's in the paper's wrong. They wrote negative 4 times half, but then it ended up being negative half. That doesn't make sense. 4 times negative half is 2, negative 2. Okay. Anyways, next part of the question. Okay, now this is definite integrals. Okay, this is the final part, and some of you may have forgotten how to do this. So we're gonna try to do this slowly and try to get our head around this. Your first goal, forget about the 0 and 1 for now. Your goal is to antiderive this. Now remember, the only antiderivative rule I've given you was antiderive ax to the power of n dx is equal to ax to the power of n plus 1 over n plus 1. Don't forget the plus c. Okay, but because it's definite integral, the plus c's are going to cancel out anyway, so you don't need the plus c at the moment. But remember, the problem with this rule is it only gives you x to the power of n. It never told you how to do something all to the power of squared, 1 minus x to the power of 2. You couldn't do that. It had to be just x. So this is a problem. So how do you remove that problem? In this particular case, there's nothing else you can do but expand. Okay, so you're going to have to expand this now. Squaring the first term, that gives you 1. 2 times x times 1 becomes minus 2x, and then square the last term, plus x squared dx. Now, each and every one of these are in the individual terms. See, look at that. They're in the individual terms. Then you can technically now use this rule. Okay, now you can use that rule. So if I use that rule, here we go. Antiderive 1. Now, for those who've forgotten again, 1 is the same thing as writing the antiderivative of 1 x to the power of 0. True? Because x to the power of 0 is 1. 1 times 1 is still 1. Now, if you write it like this, you can follow the formula above. 0 plus 1 over 0 plus 1. Yeah? So if you do that, you'll find that it becomes a, which is 1. X to the power of 0 plus 1 over 0 plus 1. I'm just using the rule, by the way. So same thing, minus 2, that's my a. X to the power of 1 plus 1 over 1 plus 1. I'm just using the rule. Plus, again, this is 1x to the power of 2 plus 1 over 2 plus 1. I'm just following the rule. Okay? That is my antiderivative. But remember, I am doing it all between 0 and 1. Now, I'm going to simplify this just so that it looks nicer. You have, that's technically just x. This is 1 plus 1 is 2, but then 2 divided by 2 cancels out. So you got minus x squared. And then this is plus x cubed on 3 between 0 and 1. Okay. Now, because it's between 0 and 1, the next step, so what I've just done is it allows you to find, we've just found the antiderivative, okay? Notice I don't have the plus c because it's going to cancel out anyway, so there's no point putting the plus c in it. You could if you want. Next step, remember the fundamental theorem of calculus is you're going to sub 1 in, so the upper boundary minus the lower boundary. So if you remember the rule is f of b minus f of a. Okay, that's from the integration of a to b of f of x dx. Then it's f of b minus f of a. That was the theory. So in my case here, I'm going to sub 1 in, and I'm going to have what? What's the first one? Sub 1 in minus 1 squared plus 1 cubed on 3. And I'm going to minus now sub 0 in. So 0 minus 0 squared plus 0 cubed on 3. And we all know that's going to answer to 0. So here we go. We've got 1 minus 1 cancels out. And then technically 1 cubed on 3 is just 1/3. There you go. That's my answer. So that's definite integrals. Okay. So the first part is what I did in this bracket here. Whoops. Oh, that looks bad. The bracket here, I'm just using this rule up here. Okay. I'm just using that rule. Nothing else. And that's called indefinite integrals. And then definite integrals is when you substitute the a and b's in. Okay? All right, next step. Question 4. Differentiate the following function with respect to x. Now, the nice thing is it's all in powers, so don't get scared, okay? Don't get scared by all the fractions and whatnot. It's the same drill. You guys did really well on this one. It's just sometimes I put a fraction in, like most of you guys got this one wrong. Do you remember the one where I gave you guys 5x squared on 2x? Yeah, that was part of your SAC. All you had to do was simplify this problem first. You weren't meant to differentiate them individually. A lot of you were doing this 10x on 2. No. You can't derive them individually. You can't just say, yeah, you know what, I'm going to ignore the fact that it's a fraction. I'm just going to treat it as if it's by itself. No. The rule that we gave you was always ax to the power of n. It was just that. It was not a fraction. It was nothing else. Yeah? And that's what you look for. You only have x to the power of n, not 5x squared over 2x. That's totally two different things. Okay? What you were meant to do here instead was simplify this first, and this becomes 5 on 2. Now x squared divided by x is x. Okay? And then find the derivative of that. Now some of you might be like, I don't know how to do that. But surely you do, because if I gave you 5x and I said, what's the derivative? A lot of you would just tell me the answer is 5. But as soon as I give you a fraction, you're like, I have no idea how to do it. It's the same drill. It's 1, drop down the 1, 1 times the 5, x to the power of 1 minus 1, right? And it becomes 5 x to the power of 0, and it becomes 5. Now, same thing over here. That's power of 1, drop down the 1, so it's 1 times 5 on 2, x to the power of 1 minus 1, and then you got 5 on 2 times x to the power of 0, and it's the same thing, 5 on 2. No dramas, the same drill. Don't get afraid. Don't be scared of fractions, okay? Because that's, to me, I think that's really sad that you're losing marks on things that you know, but you're just scared, and then you give up, or you move on to the next question because you see a fraction. And it's like a grade 3 and 4 mathematics, right? Anyways, here we go. Let's start off here. We've got dy dx is equal to, now we're going to take our time, derive half x squared. Drop down the 2. Okay, so drop down, the power rule says drop down the 2. So I've got 2 times the half times x to the power of 2 minus 1. Now if I simplify that, okay, that gives me 2 times a half, cancels out. Yeah, double halves is 1, true? 2 times half is 1. And then x to the power of 2 minus 1, which is just x. Then we do the next one. So let's focus on that. Drop down the power. So half, so this is plus half multiplied to, you got a negative 4 at the front, times x to the power of half minus 1. Okay, now half of negative 4 cancels out to be negative 2. So I got minus 2, x to the power of half minus 1 is negative half. Okay, and then we know the derivative of 7, which is a constant, is 0. Okay, so this is my, technically my answer here, but remember, you never leave your answers with negative powers. You're meant to write your answer now as x minus 2 times, now x to the power of negative half is the same thing as writing 1 over x to the power of half. Okay, that's the same thing as writing x minus, now 2 times the fraction, numerator with numerator, that becomes minus 2 over x to the power of half. Now if you haven't picked up, again, anything to the power of half really means square root. That's what square root is. It's the power of half. So another way of writing is x minus 2 over root of x. There you go. That's my proper answer. Okay? That's the derivative. You're just doing the power rule. Nothing tricky. It's just a lot of fractions and some negatives that might scare you, but that's how you do it. 1 mark. Quick and easy. Next one. Okay, so this is a chain rule problem. You're trying to find the derivative of the function, but notice, again, we don't know how to find the derivative of 5x minus 6 all to the power of 10. We'd know how to do it if it was just y equals x to the power of 10. See, if I asked you that, you had no issues. You would have just told me 10x to the power of 9. You would have done that within a jiffy, right? The only issue right now, it's not x, it is 5x minus 6 to the power of 10. So the only issue that you're really having is that 5x minus 6. So chain rule is there to help make it easier by saying, what if you made it another variable? What if you called this u? So if you let u equal to 5x minus 6, how does it change your problem. It makes it now y is equal to, instead of 5x minus 6, it is now u to the power of 10. See, that one you know how to do. So if I said find dy du, which is the derivative, you would have told me it's 10, oh wait, sorry, 10u to the power of 9. You would have done that easily. Then same thing here, du dx is equal to 5, because the derivative of negative 6 is 0. Now, what's the chain rule tell you? The chain rule says if you want to find dy dx, that's equal to dy du, which is the made up variable, that u, multiplied to du dx. So here we go. What's dy du? You got 10u to the power of 9, multiplied to du dx, which is 5, and that gives you 50u to the power of 9. But don't forget you made up u. So replace the u again. U was 5x minus 6 to the power of 9. There you go. Done. Chain rule. Quick and easy. That is the bread and butter of derivatives, okay? It doesn't matter what kind of questions you're going to get in the next 2016 or 2015 past exams. It's the same drill. Use and learn the chain rule, because that was an issue in our SAC. Chain rule and product rule. Actually, yeah, and your power rule, like, for God's sakes, if I put a fraction in there, you guys hate it. And the product rule, I literally gave you the rule. This is the next one. Differentiate. This is a product rule. What's the difference between product rule and chain rule? Chain rule is when you have a function within a function. I'll give you some examples here. If you had, normally it's e to the x, right? That's a function. If I want to make a function within a function, instead of x, I could call it e to the power of sine x. See, that's two functions. You've got an exponential and you've got a sine of x, and that's within each other. I could have another one. I could have log e. Now, normally it's of x, true? But instead of x, what if I did e to the x? That, actually, that would cancel out. Let's do sine of x. That would be a chain rule because I've replaced the x with another function. That is chain rule. But what is product rule? Product rule, product means times. So if you have two things multiplied to each other, like you have here, you've got x squared written next to e to the 5x. So that just means x squared times e to the 5. You've got two equations, two functions. Let's give you another one. Let's say sine of x multiplied to log e of x. This is a product rule. Let's do another one. Let's say e to the x times, I don't know, let's do tan of x. That's a product rule. Let's do another one. Y equals to x cubed times, let's do cos of x. This is a product rule, not a chain rule. Okay, not a chain rule. I'm not replacing the x's. I'm multiplying them. And any multiplication is a product rule. A lot of you were getting this wrong. I don't understand. It was just, I literally wrote in the SAC, use product rule, and I gave you the formulas as well. Let's have a look at the formulas, okay? In your formula sheet, it actually has the product rule. Which one's the product rule? This one. VU dash plus UV dash. It can't get any easier than that. Victoria University first is all I ever said. This is chain rule. This is product rule. Okay, what's u and v? It's the two functions that you have. I'm going to call this u. I'm going to call that v. Okay, so if I do that, u equals to x squared and v equals to e to the 5x. Your job is just to find the derivatives now. Now this one's easy. U dash is equal to 2x. Okay, v dash, I know the answer is 5e to the 5x. You're meant to get better at your chain rule by this point. But let's say you didn't know how to do this. E to the 5x. See, 5x is not what we know. According to the rules we know, we only know e to the x. The derivative of e to the x is itself. Okay? Is itself. That's it. Okay? We only know e to the x. We don't know e to the 5x. So what are you going to do? Make up another variable. Okay? Make up another variable. So let's call this, I don't know, let's call it another letter. Let's call it a. So if I let a equals to 5x, then this changes the problem to v equals e to the a. So that means, you know, the v dA, the derivative of this, will now be just e to the a. That's the reason why we use chain rule. We're just replacing it so that it looks like this. That's it. Nothing trickier. It's just to make it easier for you, right? But then remember, you made up this variable over here, a equals 5x, so you have to also find dA dx, which is 5. Now, I know this is a bit confusing because you're used to y's and x and y and u. Well, you don't have to have that. You can have dv dx is equal to dv dA times dA dx. It's the same thing. dA dA's cancel out and you get dv dx. Right? And so there we go. Now I've got dv dA, which is e to the a. So this is e to the a, multiplied to dA dx, which is 5. So what's the derivative equal to? dv dx is equal to 5e to the a, but a is the same thing as 5x. And isn't that what I just told you before? I said the derivative is 5e to the 5x. Okay? That's the long way of doing it. You are meant to pick up over time how to do the chain rule quickly, and then you'll be able to answer the question without doing all these steps that I'm showing you. It takes longer to do and a bit more confusing. But here you go. You're meant to have known this is 5. The v dash is equal to 5e to the 5x. Okay? All right. Now that I've got v and v dash, u and u dash, according to the rule, then dy dx, which is using product rule, is vu dash, v, which is e to the x multiplied to u dash. So e to the 5x multiplied to u dash, which is 2x, plus u, which is x squared, multiplied to 5e to the 5x, v dash. Rewrite it as 2xe to the 5x. I like my numbers at the start and pronumerals next. Plus, this is 5x squared e to the 5x. And you can simplify that if you wanted to. They both have a common factor of x and e to the 5x. Yeah, you can technically write it as take out the x, take out e to the 5x, and you're left with 2 plus 5x. Okay, that's usually the better answer for year 12. All right, did they do that for your case? Yes, they did. They did it in your solutions as well. Okay, they just factorized it. And they just use product rule. So I'm actually describing it in detail right now. So if you're looking at the solutions, you have no idea, they use product rule. Okay. All right. Question 5. Hey, we're on the last page. Woo! Almost there, guys. Here we go. So, question 5. Determine the stationary points. Now, for those who haven't been listening or forgot, stationary points just means when the derivative, so f dash of x, derivative equals 0. And if you've forgotten, what's the purpose of derivatives again? It is to find the gradient. There's nothing else trickier than that. It is just to find the gradient of a tangent line at one point. So this is really just saying when is the gradient equal to 0. And remember, gradient of a tangent line to be 0, it just means that it's a horizontal line. The only time you're going to have a horizontal line is you have a maximum. That's when the tangent line is horizontal, and the minimum. Or you have a point of inflection. Those are the only times. So you got a max, you got a min, and you got an inflection point. Yeah? There's only 3 points. So it says determine the stationary points. It just means find the derivative and let it equal to 0. That's what we did today's lesson with max and minimum problems with your CAS. So here, determine the stationary points of f of x. I just need to find the derivative first before I can let it equal to 0. So what's the derivative? F dash of x equals 2. Now this is all power functions, so that should be 3x squared plus 18x plus 24, and the last one 0. Okay. What's my next goal? I want to solve, because I know at the stationary point the derivative equals 0. So this is equal to 0. 3x squared plus 18x plus 24. Now I notice they're all factors of 3, so I can take out 3. X squared plus 6x plus 8. And then divide both sides by 3, and I still get 0 there. So this now becomes x squared plus 6x plus 8. See if I can factorize it. X, 4 and 2, plus. Yes, it works. Therefore, using null factor law, x plus 2 has to equal to 0. So that means x equals negative 2. Or x equals to negative 4. Now, those are stationary points. Now, they told me to use a gradient table. Gradient table is the sign diagram, by the way. Okay. Sign diagram to justify their nature, because I only found the stationary points. I don't know if it's a maximum, minimum, or point of inflection. That's what I don't know. Okay. Actually, I want to move this across. I wonder if I can move this. How do I move it? Can I do it like that? Oh, hey, that works. Cool. I'm going to move it up a bit. There we go. Okay, now let's use a gradient table. So gradient table, I'm going to do this. I'm going to just draw some lines down. And I'm going to start with x dy dx, because that's the gradient. Okay, well, I'm going to use f dash of x. Okay, and then I've got the sign on the gradient. Now, what were my points? I found that when x equals -2, so let's say -2 is here, okay, and x equals -4, so let's say -4 is here. Notice I left a gap in between each one. Now, I know the gradient at these points was 0, because that's what I said before. I said the gradient equals 0. So I know the gradient is 0, and it's a horizontal line, horizontal line. Now, remember, in order for you to have a maximum, see, this is the tangent line. That's when gradient 0. But if it's a maximum, if it's a max, local maximum, then the point before it has to be a positive gradient. And the point after has to have a negative gradient. So all you have to do now is to choose a number that's after -2 and then before -2 to see what the gradients are. Because if it's like this, then you can say that's a maximum. So if it's positive, then negative. If it's negative and then positive, that's a minimum. And then if it's like both positive or both negative, it's point of inflection. So let's pick a number. I would probably pick -3 just to make it easier. And between... Actually, no. Wait. I'm confused now. I've got the numbers in the other direction, so... I like it in order, okay? You might not care, but I do. So -4 and -2. So if I were to pick numbers, 0, I would pick 0 because it's greater than -2. And what's between -2 and -4, I put -3. And what's smaller than -4, I put -5. Okay, so I put it in order, and I'm going to test the numbers. So what am I testing for? I want to know what is the gradient when x equals 0. So, or x equals -3, and when x equals -5. Now, how do I find the gradient? Well, you got the equation here. See, a lot of students forget the purpose of finding the derivative. They don't even know why they're doing the derivative. They just do it. But you have to remember the derivative tells you the gradient. This right here tells you the gradient. So if that's the gradient, then if you sub 0 in, you'll find the gradient. Think about it. If I did f dash and I sub 0 in, I'm just really finding f dash means gradient. And I just sub 0 in. So you got 3 times 0 squared plus 18 times 0 plus 24. That gives me 24. 0 and 0. So if this is 24 when x is 0, that's a positive gradient. Number 24 is a positive number. The gradient is 24. So it's a positive gradient. Okay, so it's positive gradient. Then I do the same thing for -3. So f dash -3. If I sub -3 in, 3 times -3 squared plus 18 times -3 plus 24. Here we go. -3 squared is 9. 9 times 3 is 27. Minus, oh my god, what's 18 times 3? That's 4, 2, 3, 54, I think it is. -54, am I right? Let me double check that. 3 times 8 is 24. 4 carried to 2. 3 times 1 is 3, plus 2 is 54. All right, cool. So 27 minus 54 plus 24. Okay. I would probably do 27 plus 24. So, and that gives you 1, 1. So 51. 51 take away 54 is -3. So I know the answer is -3. What does that matter? That just tells me the gradient is -3 when x is -3, and it's a negative gradient. So it looks like this. So clearly at -2, this is a local minimum. Because the gradient's negative, and then it goes 0, and then it goes back to positive. So it's the other way. See, it has to be a minimum. I'll draw the minimum. This is a minimum point. This is when it's 0. Anywhere before it, clearly that's a negative gradient. Anywhere afterwards, positive gradient. Clearly, it has to be a minimum. So it fits that. It fits that pattern. It's, you know, negative, then positive. Then I got to test the last one. -5. Now, -5, what does this tell me? I got to sub in -5 to find out. So f of -5, I'm not liking this because the numbers are too large. -5 squared plus 18 times negative 5 plus 24. Whoever made this question is still a waste of time. Just because it takes too long. Should have made the numbers smaller is what I'm trying to say. Anyways, here we go. 3 times 25 plus 18 times 5. What's that? 0, 4, 5, 90. So negative 90 plus 24. 3 times 25 is 75 minus 90 plus 24. Okay, 75 plus 24. This is what I don't like. Like, why are we doing long addition? It's like we're not being tested on this. Anyways, 99. So this is 99 minus 90 gives you 9. Okay, so that gives me a positive number. So 9, positive gradient. So what does that tell me? If you've got a positive gradient, then a zero gradient, then a negative gradient, that clearly is a maximum. So now you can say this is a local max. There's a lot of steps, only because the numbers are just so large to justify it. It just took a long time to get those 3 marks. I don't approve of that question. I think it takes too long to do. It's not hard, it was just tedious. Anyways, next one. The curve y equals ax squared plus bx plus c contains the point 0,5. So that should tell you something. Remember when I said read the question and take line by line? You got y equals ax squared plus bx plus c, and it says it contains this point. It just means when x is 0, y is 5. So why don't you just sub it in, test it? You know, like, don't give up straight away. Like, y equals 5, so 5 equals a times 0 squared plus b times 0 plus c. And what you'll find is 0 plus c, and therefore c is 5. You already just found c. Yeah? Cool. You found c. Now, it contains the 0.5, and then it says stationary point. What does stationary point mean again? The derivative is 0. So what that should already hint to you is find the derivative at x equals 2. Okay, at 1 point at x equals 2. So here we go. Let's find the derivative at x equals 2. So derivative of y equals to ax squared plus bx plus c. The derivative dy dx is you drop down the power 2 times a, x to the power of 2 minus 1, so 2ax. And derivative of bx is just plus b. Now I want the derivative to equal to 0. So 0 equals 2a x plus b. Now the derivative is only equal to 0 where? At x equals 2. So when x equals 2, 2 times a times 2 plus b, you get 4a plus b equals 0. Okay, so you got an equation. This is your equation 1. Where you're going to find your next equation, a lot of students forget this step, and this comes to my year 12s as well. You know a stationary point means the derivative. So you got the derivative and the x, but don't forget you also have x and y. So this just tells me when x is 2, y is negative 14. So use it. Use that negative 14. They didn't just give it to you for nothing. You know, so the equation was, again, y equals to ax squared plus bx plus c, but we now know c is 5. And they just told you when x is 2, y is negative 14. Put it in. You get your 2 equations. Here we go. Negative 14 equals to a multiplied 2 squared, which is times 4, plus 2b plus 5. So minus 5 on both sides, that becomes minus 19. 4a plus 2b. There you go. You now got your second equation. You can simultaneous. So here we go. I'm just going to write it next to each other. Negative 19 equals to 4a plus 2b. This is my second equation. And what I would probably do is say take equation 1 minus equation 2. So 0 minus negative 19 gives me positive 19. 2 negatives make a positive. 4a take away 4a is 0. And then b take away 2b is negative b. Yep, so negative b equals to 19. Therefore, b is negative 19. So now I got c, I got b. How do I find a? Well, sub it back into either of the 2 equations. It either had this one or that one. Equation 1 or 2. I would probably pick equation 1 because it has no negatives. It has a 0 in it. So 0 equals to 4a plus b. Something's wrong with my aircon. Now b was minus 19, so minus 19, add 19 on both sides for A, and A equals to 19 on 4. There you go. Done. Answered the questions. Too easy. Okay, so you got 19 on 4, negative 19. So really, what was tricky about this? It was probably simultaneous, maybe some fractions that you don't like. But really, the information that I've been using, it's the same thing over and over. In fact, I did the same thing for your SAC. Okay? Every one of these questions will have an x and a y and a gradient and an x. That's just how it works. Okay? Gradient. I'm going to turn off my... Alright, something's gone wrong with my aircon. Hold on a second. Alright. So, it's always got to do with the relationship between y and x and the gradient. The gradient and x. These two. Okay, you got your gradient and x. That's one information, and you'll have another one where they have to give you the relationship between y and x. It's always there. Most students overlook it. And remember, it's the purpose. Don't forget the purpose. You forget the purpose, you don't know what the derivative is, you don't know why you're doing it. I promise you, you will always find this hard. And it's the same thing you do all the way to year 12. Year 12 next year is the same thing. Stationary points, gradients, and y and x value. It's the same drill. I promise you, you'll see the same things. Okay? There you go. That's exam 1 of 2017. I think that took me about just an hour to do. Where's the recording? Anyways, I'm going to stop here and leave you to watch it again. That's exam 1. I'm going to post it. It's probably going to take a while to upload, but in that meantime, I'll do exam 2 with the CAS. So get your CAS, get ready. We're going to do this before I go to sleep, wake up, and go to camp. Okay? All right. Best of luck.